Today we will be talking about Lewis structures. A Lewis structure is the symbol of an element and one dot for each valence electron.
This is the Lewis structure of boron. Boron has 3 valence electrons, so there are 3 dots around its symbol. Refer to your periodic table to see how many valence electrons are in an element.
These lines show the different types of bonds. A single bond has 1 line, and it represents 2 electrons. A double bond is shown by 2 lines and represents 4 electrons. A triple bond is shown by 3 lines and represents 6 electrons.
On the right is a Lewis structure for the compound H2O. Each one has a single bond, which represents 2 valence electrons. Each element in a compound is happy with 8 electrons surrounding it. There are exceptions. Hydrogen and helium only need 2 electrons. Boron and beryllium only need 6 electrons to be happy. Now we're going to show you how to make a Lewis structure. First you have to figure out which atom is in the center. The atom with the smallest electronegativity is in the center, which in H2O it would be O. Next, you're supposed to count the total number of valence electrons. A hydrogen molecule has 1 valence electron, but since it's H2, you count it twice. And oxygen has 6 valence electrons. When you add them together, you get 8. So first you draw a single bond on each side connecting the H's. Since each one of the single bonds represents 2 electrons each, you would subtract 4 since there's 2 of them. And then you would end up with 4 left. And since hydrogen is happy with only 2 electrons connected to it, you can use the last 4 to go around oxygen. So now oxygen is happy with 8.
Let's try a more complex one. This is perchloric acid, HClO4. First we find out which atom is in the center, and since Cl has the smallest electronegativity, it goes in the center. And then you surround it with the oxygens. And then you can connect the hydrogen to one of the oxygens, because hydrogen always has to be on the outside. And we already added up the number of valence electrons, and we got 32. And since there are 5 single bonds, you subtract 10 from the number of valence electrons, leaving you with 22. Now surround the remaining oxygen with dots. 1 dot equals 1 valence electron. This oxygen over here only needs 4 dots around it, since there are 2 single bonds surrounding it, leaving it with 8 valence electrons total. Now count the total number of dots that you have to make sure that you have 22 dots. And once you do, you subtract that from the number you had before. And since you have 0, you used all your valence electrons and you completed the Lewis structure.
Okay, now go ahead and try SO2 on your own. Pause the video if necessary. Now we will talk you through how to make the Lewis structure for SO2. Sulfur has 6 valence electrons and oxygen has 6. But since it's O2, you add those together and you get 12. And all together you get 18 valence electrons. S has the smallest electronegativity, so that'll be in the middle. And then you connect the oxygens on the outer parts of sulfur. Since you use single bonds to connect the oxygens to the sulfur, you subtract the valence electron and that each line represents 2, so you should subtract 4 from 18 and you get 14. Once you figure out that you have 14 valence electrons left, you distribute them around the oxygens. That's 12, and you only have 2 left, so you put them on the sulfur. But then you realize that sulfur only has 6 around it. It doesn't have 8, so it is not happy. You then figure out that you would have to make double bonds. So you would erase the valence electrons on O and add a double bond. Now the sulfur molecule is happy because it has 8 valence electrons surrounding it, and so are the O's. So this is your final Lewis structure for SO2.
Okay, now let's recap. A single bond represents 2 valence electrons. A double bond represents 4. And a triple bond represents 6. And then some of the exceptions are hydrogen and helium are happy with 2 valence electrons. And boron and beryllium are happy with 6. And hydrogen always has to be on the outside of the Lewis structure.
And this brings us to the end of our video.
Good luck!